Okay, so can you guys see my screen now? Oops.
Yes, sir.
Millman's muna tayo.
So,
Okay. All right, so wait. So for the last two topics, so I hope we can finish this one in just within 30 minutes only, since this one is super easy. So Millman's theorem is another method, of course, wherein we can get the voltage across this R1, voltage across this R2, R3, or the current across R1, R2, and R3. Okay, just another or a different ways, of course. Okay, so in this theorem, in Millman's theorem, the circuit is redrawn as a parallel network of branches, each branch containing a resistor or series battery resistor combination. So Millman's theorem is applicable only to those circuits which can be redrawn accordingly. Okay, so just take note that if there is no series connection, let's say you only have one voltage source in here, and then you only have one resistor and then another voltage source. So yes, they are in parallel. Okay, we could say that they are in parallel branches, but for us to be able to see that, we can say that we can apply Millman's theorem. So there must be two components at least. Okay, so what are those two components? So one battery and then one resistor, which is in parallel, I mean in series with each other. Okay, so that's one. Okay, if you have this one and then another more okay branches that has a battery and then a resistor, then better. Okay, but there are also some cases wherein it can be that there is no battery, something like this. Okay, like on the R2 it doesn't have a battery. Okay, just take note that there must be at least two branches that has a battery and then a resistor. Okay, but if there is only one, then you cannot apply Millman's theorem. So this is already the minimum. Okay, let's say a count of components that you can have if you're going to apply Millman's theorem. So there must be at least five components. One, two, three, four, and then five. So you can have more. You can have another branch right here. Okay, as long as you already have, let's say, two branch that has two, uh, let's say, two resistors and then two batteries, which is in series with each other. Okay. All right. So here again is our example circuit used for the last two analysis method. Okay. So we're going to show that the values that we are going to get in here is the same with the past theorems that we have discussed. Okay. All right. So here is the same circuit that is redrawn from this circuit. Okay. So we've just made them more obvious that they are in series with each other. So we have this left side branch which is in series with each other, and then the right side branch which is in series with each other also. Okay. So when applying Millman's theorem, this is very important. Okay. So this one is considered as a parallel connection to this one and to this one. Okay. The same with the R2. This one is in parallel, okay, with this one and then this one. So the same with R3. This one is in parallel with R2 and then with the left side branch. So all in all, they are uh, in parallel with each other. Okay, so three branches in parallel with each other. So by considering the supply voltage within each branch and resistance within each branch, Millman's theorem will tell us a voltage across all branches. So the one that we let's say we will get, okay, initially, okay, for us to be able to apply this Millman's theorem is of course to use the formula that will be given to us later on. Okay, and then whatever is the result, that is the voltage. Where is it? One, that is a voltage, okay, across all branches. Okay, meaning that is the let's see stabilized once everything was connected. Let's see, 7 volts and then 28 volts is connected. So the total voltage that will be solved is the voltage across those branches. So in branch 1, branch 2, and branch 3. Okay, so here's the formula that you guys need to memorize. Okay, so this is one easy theorem also, because all you need to do is memorize this formula, and then you have this kind of circuit, and then you can now apply this kind of formula. Okay, so this one is also super easy to memorize. So if you guys are going to take a look on this one, it's like having the summation of currents, okay, divided by the 1 over, it's like the summation also of the resistance, but we have a numerator which is on the top of it. So 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so we have this three voltages, okay, and then the three resistances. So we have EB1 right here, and then we have EB2, and then we have EB3, okay. But if you guys are going to take a look on this one, we don't have EB2, so no problem. Just leave that EB2 0, okay, or just make that one 0, just something like this. And then you can now solve everything, okay, using your calculator. And then you will get 8 volts, okay. So there is no, tricky part in here. As long as you know this formula and then you have this kind of setup, then you will get the answer as fast as you can, okay. Basta tama yung mga values nyo. Okay, so in here, the voltage that we have solved is 8 volts. Okay, meaning that is the voltage across those branches. Okay. So I'll give you guys 1 minute, maybe 30 seconds to 1 minute to analyze this one. Okay, napaka straightforward naman. So, yan na lang pala. Para may basis kayo. Okay. So, tingnan nyo lang kung saan nanggaling yung EB1, saan nanggaling yung R1. And then let me know once everything is already okay. Okay, so just give me a thumbs up after that.
Yes, sir. Nagasa mo.
SD. So, sobrang dali lang neto. So, yun na nga, since open notes, I think wala kayong magiging problema. As long as you were able to simplify this circuit, something like this. Okay. So, again, I will repeat. This is already the standard form when it comes to forming a Millman's theorem. So, let's say walang R1 and then walang R3. You cannot apply this one. Okay? So, dapat meron at least dalawa. Okay? Dalawang branch na merong battery at saka resistance. Okay? So, dapat meron ito, meron ito. And then, the rest, let's say kung mag-extend pa dito kahit isang resistance siguro, then okay lang din. Okay? So, ang magmamatter lang naman is as long as meron ka ng dalawa for you to be able to apply this one. So, kung meron pang isa dito, so just make this one plus EB4 over R4 and then sa baba naman plus 1 over R4. Okay? So, as simple as that. Anyway, so ito na nga yun. Yung nakuha nating voltage is 8 volts, okay, across all of your branches. So, in here, na-deduct na kumbaga. So, parang nasabi natin merong 8 volts na dumadali dito. So, yung parang naging voltage across this resistance is now 20 volts. Okay, due to these 8 volts. Okay, so the same with this one since wala namang positive or negative battery dito. So, 8 volts na kagad yung dumadaloy. Okay? And then the same with this one. So, by default, we have 8 volts again flowing in this branch. So, we just deducted this 7 volts right here. Thus, having a 1 volt voltage across this R3 right here. Now, how did we get those values? So, we have the computation part right here. Okay? So, the one that will dictate, okay, so paano nyo malalaman kung tong positive ba to or negative? Okay, so this is very, very important. Please listen carefully kasi baka mapagbaliktad. Okay, so just by applying the formula that I gave to you guys, I showed to you guys a while ago, we've got a value of 8 volts, right? So in here, how will you know if this is the positive part and then this is the negative part? Okay, so basically wherever is your reference point. So when I see reference point, that is at the ground. Okay, that is your negative sign. Okay, so that's why we have the negative sign right here. And then wherever is a positive part of your, let's say, battery or positive side. So nandun din yung positive na sign neto. So another thing that you can check is the polarity of your batteries. So in here, it's very obvious. We have negative in here, okay, which is the same with the reference point, which is 0 volts. The same with this one, we have negative in here, which is the same with the reference point, which is, of course, 0 volts. So we can easily identify that the voltage across these branches is with, having this kind of polarity. So negative sa baba and then positive sa taas. All right. And then, how did we get those values? 20 volts right here, 8 volts right here, and then 1 volt right here. So, dito yung computation. So, solving for resistor voltage drops. So, in here, we just have a pattern, okay, wherein, if you guys are going to take a look at this one, the one that we have solved for, the voltage across on our entire circuit, okay, or all of our branches. So, unahin nyo lang yon and then deduct, okay, the battery that is on that branch. Okay, so for branch number 1, we have 8 volts minus 28. Okay, and then 8 volts naman sa pangalawa, of course, 8 volts pa rin minus 0 volts. Okay, and then for the last branch, it's 8 volts minus 7 volts. So that is why we have those values, 20 volts in here, 8 volts in here, and then 1 volt in here. Okay. So are we clear on how did we go? How did we get those voltage drops across R1, R2, and R3? Okay, so ulitin ko lang. Una yung computed. Okay, computed. So ito is voltage across resistors. Okay, computed voltage. Ano kayong tawag natin dito? Across the branches. Okay, since isa lang naman to, which is 8 volts nga, minus the battery source on each on that specific branch. Ganun na lang. Alright. So, I hope you guys can see this one. So, for you to be able to get the voltage across your resistors, so it's computed voltage across the branches, which is 8 volts, minus the battery source on that specific branch. Okay, so in here we have 28. So, and then in here we have 0, and then we've got this one, and then in here we have 7 volts. Okay, so that's how we've got the voltage drop value. Now, what about the current? So in here, to solve for branch currents, each resistor of voltage drop can be divided by its respective resistance. So gamit lang kayo ng Ohm's law. Very obvious naman na to. As long as you have the individual voltage drop, okay, that is flowing on that specific resistor, then you can now get the specific resistance that a specific current, okay, that is flowing on that resistance. So IR1 is equal to 20 divided by 4. So 4 came from this R1 right here. Balikan natin yung value ng R1. R1 is this one, 4. Okay? So, kunin ko na lang to. And then, let's now solve for the current. Okay? So, just apply I is equal to V divided by R. Okay? So, if it's I1, then of course, it must be the V1, okay, or VR1, voltage across R1, and then the R1 itself. So in here, meron tayong 20 volts, meron tayong 8 volts dito, and then we have 1 volt in here. So VR1 is 20 divided by 4. So we will get 5 amps right here. So for the R2, so it's 8 divided by 2. Diretsuin ko na, which is 4 ampere. And then in here, we have 1 divided by 1 is equal to 1 ampere. Okay. So 5 amps, 4 amps, and then 1 amp, which is the same with our computed value. So 5, 4, and then 1. So are you guys able to follow on how did we get those values on IR1, IR2, and IR3. Okay, what about the rest? Mr. Carlo, Mr. Francis. Okay, very good. Mr. Michael. Ms.
Nagagets
Chris.
naman, sir.
Mr. Nathaniel. Okay, very good. So basically, yun na yun. Okay? And then, ito na yung final result ng ating computed value. So we have 5 amps flowing in here. We have 4 amps flowing in here. And then 1 amp that is flowing in here. Now, how do we identify if the current is really flowing in here, and then flowing in here? So, basic analysis na lang siguro to. I think, sa unang tingin pa lang kasi, kapag nag-a-analyze kayo, malalaman nyo na kaagad, okay. So, kuha na lang pala ako ng wala pang label. Ito na lang. Okay, so if we are going to analyze this one, let's say we don't need to compute the values for the current. This one, we don't need to compute the voltage drop across this one. Just by just by looking at it, you already know how the current will flow on this entire circuit. So first, alamin nyo muna yung pinakamataas na voltage source, okay, yung source natin. So remember our thumb up rule when it comes to rule of thumb, okay, when it comes to uh, let's see, voltages and then currents. So we have this VH minus VL, okay, which is that is now the final potential value, okay, that you will get in there. So the same with the current, we have IH minus IL, okay. So pares na final potential current, okay, parang ganun. So in here, it's always the bigger, okay, that will dominate the entire circuit, and the smaller will be deducted on that bigger source. So in here, if you guys are going to take a look at this one, kung magbabase tayo sa sign, okay, we have this flow of current, negative to positive, and then we have this flow of current. So basically, we have an opposing voltage, but as you guys may already know, it's either it will be added or it will be deducted on our voltage source. So in here, this one will be deducted since uh, it is opposing this higher flow of voltage in here. So parang mangyari niyan, this one will become like this, and then this the value of this one will be deducted on this 28 volts right here. Okay, so that is why we have this flow of current right here and then flow of current right here, which is now the same, okay, with this one. Okay, 5 amps, 4 amps, and then 1 amp. Okay, so are we clear with this one so far?
Yes, sir.
Okay, so one last thing I forgot to mention. So as you guys can see, we have a sign right here, which is the positive, negative, and then positive, negative. So in here, we've got this one from this solved values of our voltage drop on each resistor. So as you guys can see, we have negative 20 volts, 8 volts, and then 1 volt. And then it says here that we have negative on top. Okay, kasi meron tayong negative sign dito. Okay, so remember that I mentioned a while ago that we have the reference point, okay, which is this one. So mostly, of course, negative to, negative, negative, and then positive to, and then positive rin to. Okay, that's why we have this 8 volts right here. Sign. Ito yung para magiging sign na to, positive and negative. But then again, okay, when it comes to voltage drop, okay, so the one that will dictate of the polarity of our resistor is this computed value right here. So if it says here negative on top, then just put on the ER1 negative on top. So negative right here and then positive below, of course. So for the ER2, we have positive on top. So just make this one positive and then make this one negative. Okay, and then the last one positive on top, then make this one positive and then negative right here, which will give us this kind of circuit right here. Okay, so are we clear? Hello? So do you guys have a question so far? Hello? You guys still around? How about the others? Okay. So kala ko na-busy na ako eh. Kasi wala na sumasagot. Anyway, so this is already it for the Millman's theorem. And then the rest are just, the summary or the conclusion. So this is another theorem which is very convenient for determining the voltage across a set of parallel branches. Okay. Where there are enough voltage sources. Okay, and however, it is limited in that it only applied to circuits which can be redrawn to this form. Okay, or yung sinabi ko kanina which is uh, may dalawang batteries and then dalawang resistance. So it cannot be used, for example, to solve an unbalanced bridge circuit because you cannot simplify that one into a parallel branches. And even in cases where Newland's theorem can be applied, the solution of individual resistor voltage drops can be a bit daunting to some. Okay, the Millman's theorem equation only providing a single figure for branch voltage. So as you will see, each network analysis method has its own advantages and disadvantages. So each method is a tool, and there is no tool that is perfect for all jobs. So that is why having as many tools as you can have is a perfect, okay, perfect thing or a perfect weapon that you can bring anywhere when it comes to solving a, let's say, a voltage drop or a current on a specific path or node. Okay. So here's the reference. So this one came from All About Circuits, and then I attached here another websites which you can also visit. Okay, to have more knowledge when it comes to Millman's theorem. So yeah, this is already very obvious, and then uh, I've already mentioned this one a while ago. Okay, and then we have sample videos here, so make sure to visit those YouTube link. Okay. So that's it for the Millman's theorem. And kaya ako nga pala binuksan tong superposition because I would like you guys to show that we have the same result. Okay, so this is the result for the superposition theorem: 28, 5 amps, 4 amps, 1 amp, 7 volts, which is the same with this one. Okay, 28, 5 amps, 4 amps, and then 1 amp. All right. So, nevertheless, of what uh, let's say tool or theorem you're going to use, it will still give you the same result as long as you did the correct solution, of course. Okay. So, any questions so far regarding with the Millman's theorem? Questions or clarifications? Hello? Are you guys still around? Hello, hello, hello.
Sir, wala naman pong questions.
Okay. So, okay. So, kung wala na, then we can now move on to maximum power transform theorem, which is the last module for your finals. But since we don't have enough time anymore, okay, so I will stop our meeting now and then I'll just create another link so that we can have enough time to discuss the entire module 12. 12. Yes, module 12. Okay, so goodbye for now and then see you guys later.